Today we're going to talk about the mole, more specifically Avogadro's number. In this lesson you're going to do two things. One, you're going to compare two samples conceptually using the mole concept, and you'll be able to use the Avogadro's number to convert between amounts in mole and number of particles. So let's first start with things that we know. First of all, we all know 1 dozen is equal to 12, and 1 ream of paper is equal to 500 pieces of paper. These are what we refer to as conversion factors. Remember, conversion factors are used to convert between two different units using factor label or dimensional analysis. And remember, a conversion factor is something that is equivalent to each other, but they have two different units on them. So if we take a look at this penny, how many atoms do you think are in this penny? A way that we can help solve that problem is by using the mole. The mole is the chemist's counting unit. It tells us how many particles of a substance that we may have. 1 mole is equal to 6.02 times 10 to the 23rd. That is an extremely large number. Why do you think the mole is such a large number and we would use it in chemistry? 1 mole of any element is equal to 6.02 times 10 to the 23rd atoms. So if I had 1 mole of potassium atoms, I would have 6.02 times 10 to the 23rd atoms. If I have 1 mole of magnesium atoms, I would have the same amount. Just like a dozen. If I have 1 dozen donuts, I have 12 donuts. If I have 1 dozen cars, I have 12 cars. Same thing with the mole. The mole can be used as a conversion factor because those two things are equivalent to each other. So let's take a look. I have 1 dozen donuts and 1 dozen giraffes. What do these two things have in common? How are they similar? My 1 dozen donuts and 1 dozen giraffes, how are they similar? Is because I have 12 of each. I have 12 donuts and I have 12 giraffes. Now, how are these two things different? My 1 dozen donuts and 1 dozen giraffes. These things are different because they have different masses. Obviously, my 12 dozen donuts does not have the same mass as my 12 dozen baby giraffes. Now, what if you have 1 mole of donuts and 1 mole of giraffes? How are these two things similar? These two things are similar because I have the same amount. I have 6.02 times 10 to the 23rd donuts, and I have 6.02 times 10 to the 23rd giraffes. Now, same question as I did with my 1 dozen. If I had 1 mole of donuts and 1 mole of giraffes, how are these two things different? These two things are different because they have different masses. So now let's take a look at a molecule. How many hydrogen atoms are in my 1 molecule of H3PO4? I determine the number of atoms in my molecule by looking at the subscript. I have 3 hydrogen atoms in my 1 molecule of H3PO4. How many phosphorus atoms are in 1 molecule? I have 1 phosphorus atom in my H3PO4. How many oxygen atoms are in 1 molecule? Again, we look at the subscript. There are 4 oxygen atoms in the molecule of H3PO4. How many molecules are in 1 mole of H3PO4? Well, the previously learned, we know that if I have 1 mole of anything, I have 6.02 times 10 to the 23rd molecules. So in 1 mole of H3PO4, I would have 6.02 times 10 to the 23rd molecules of H3PO4. Now let's take a look at each individual atom. If I have 1 mole of H3PO4, how many hydrogen atoms would I have in 1 mole of H3PO4? I have my H3PO4, and I have 1 mole of H3PO4. And in 1 mole of H3PO4, I have my 6.02 times 10 to the 23rd molecules of H3PO4. So that gets me to molecules. However, I just want the number of hydrogen atoms. So in one molecule, I have 3 hydrogen atoms. So in order to then solve this out, all I would have to do is multiply 6.02 times 10 to the 23rd times 3. So I would end up with 1.8 times 10 to the 24th hydrogen atoms. And how many phosphorus atoms are in 1 mole of H3PO4? I have 1 mole of H3PO4, and in 1 mole there are 6.02 times 10 to the 23rd molecules. And in 1 molecule, be careful in abbreviating molecule. I prefer for you to just write it out. There is 1 phosphorus atom. So in this case, if I have 1 mole of H3PO4, I would have 6.02 times 10 to the 23rd phosphorus atoms. Let's take a look at hydrogen or oxygen atoms. How many oxygen atoms are in 1 mole of H3PO4? Instead of this number being 1, what should it be? Reminding you, in order to determine the number of atoms in a particular molecule, we look at the subscripts. So in 1 mole of my molecule, I have 1 mole, 6.02 times 10 to the 23rd molecules. And in 1 molecule, I'm going to change this to 4 oxygen atoms. So in order to solve this, I'm going to multiply 6.02 times 10 to the 23rd times 4. So in 1 mole of my H3PO4, I'm going to have 2.4 times 10 to the 24th oxygen atoms. The thing you need to remember is if I have 1 mole of anything, I would have 6.02 times 10 to the 23rd of those things.